Hello everyone. I'm delighted to welcome you to our event this evening. What has the engineering response to COVID-19 looked like, which we're holding in partnership with Inter Engineering. I'm Polly Williams, I'm Head of Diversity and Inclusion at the Royal Academy of Engineering, and this event forms part of our celebration of LGBT STEM Day, which is today. And we have a great lineup of speakers for you this evening who are going to share some of their experiences about working through and responding to the crisis. And we'll also be discussing how to keep inclusion and equality in mind and at the centre during times of turbulence, transition and uncertainty. I just want to say a couple of words about the Academy. One of our key strategic priorities is to support the development of a world-leading and truly inclusive engineering workforce in the UK. We're all aware of the diversity challenge facing the profession. Engineering has both a significant skill shortfall and a diversity deficit. But improving diversity alone isn't enough. We also need to build and maintain inclusive cultures in which engineers from all backgrounds feel that they are welcome, valued, and able to contribute to the full and perform at their best. And engineering needs people with different skills and experiences and ideas and perspectives to make sure we're in the best position to respond with creative and innovative solutions to the problems our world will face. And engineers are playing a hugely important role in shaping the world that we live in, not least in the engineering response to the current COVID crisis, which we'll be discussing tonight. So it's even more important that the engineering profession is reflective of the society it seeks to serve. So at the Academy, we're working with partners including engineering organisations, employers, professional engineering institutions, as well as networks and others such as Inter Engineering to boost the numbers and the diversity of those entering engineering careers and to catalyse a step change in the diversity of the workforce and the prevalence of inclusive cultures across engineering industry. So through our diversity and inclusion leadership group, we work with engineering employers to share best practice and co-create practical tools to promote inclusion in the workplace. And I just want to mention two resources that you might find of interest and relevance to this evening. So we launched our team workshop series in September, which is an interactive set of workshops designed to help you create an inclusive team culture and get projects off to a positive start. And that series includes an interactive workshop on the link between increased diversity and inclusion and better problem solving, which seems highly relevant for today's conversations. And our Majority Allies resources are for those who wish to be an ally and for organisations looking to set up an allies programme as part of building and sustaining an inclusive culture. And a little bit of flavour of some of the upcoming things that we have, upcoming projects. We recently launched a campaign aimed at delivering a fellowship that is fit for the future by the time the Academy celebrates its 50th anniversary in 2026. And that's a fellowship that embodies the full breadth and diversity of engineering excellence. So we're seeking to elect more outstanding candidates from underrepresented groups, which includes female, Black, Asian, minority ethnic, LGBT+ and disabled engineers, as well as those that are coming into engineering via non-traditional routes or achieving excellence at an earlier career stage as is typical. And we've set an aspiration that at least half of all candidates elected each year will be from those underrepresented groups. And we're also exploring the development of a mechanism to engage, support and challenge engineering companies to make progress on diversity and inclusion. And we're currently undertaking an exercise to learn lessons from existing mechanisms out there and consulting with a wide range of stakeholders across the profession. And we'll share more details on this work in the coming months with you. So we are continuing to look for ways to accelerate the rate of change and increase the representation and experience of underrepresented groups in UK engineering. So tonight we're going to look at how our profession has responded to the challenges of COVID-19 to recognise the contribution of LGBTQ+ engineers in addressing these challenges and to look at the lessons and experiences we can learn from now to ensure that in future times of turbulence, transition, uncertainty, we can respond in a really inclusive way. I'm really looking forward to the panel discussions later on. So I'm delighted to hand you over to Dr. Mark McBride-Wright, who is Chair and Co-founder of Inter Engineering. He's our wonderful host for the evening and will be chairing our panel. And I'd like to hand over to Mark to introduce our speakers. Mark.
Hi, Polly. Thank you, and thank you to everyone for joining us this evening. I'm Mark McBride-Wright. I'm founder and one of our directors at Inter Engineering. It's great doing sessions like this now. Moments like this always make me reflect back to when we set up Inter Engineering 6 years ago, to connect, inform and empower LGBT+ engineers and supporters. And so much has changed even in that short time. We've seen a real growth in our network, a real growth in our membership, and the events that we do have changed over time as well. We went from an organisation that was very London-centric, running events, to then running national events and coordinating participation at Prides, to this year running more digital-based events with our successful Re-Engineering Pride series that took place in August. I just wanted to flag up that we do have a digital networking event happening on the 17th of December. So please, we'll send round information on that. And this makes, it's important to be doing events like this because it shows the importance that's now being placed on lesbian, gay, bisexual, transgender and non-binary plus community within engineering, because it's a hidden identity. In our experience, it's still an area of diversity that is very awkward. We're starting to get some enlightenment, but very often we see that monitoring and measuring infrastructure isn't there to actually know truly the composition of our workforce on hidden identities like sexual orientation and disability. So it's my hope that as we do more of these events, as we showcase the role that LGBT+ engineers are playing in engineering, that we can open up a new pathway for talent into the profession through LGBT youth groups, and also encourage more LGBT+ engineers who are either in the closet, who are struggling to come out at work, who are facing a dilemma around their safety being posted overseas, etc., in non-inclusive countries, where our safety would be at threat. Really creating a culture organisationally where people can feel comfortable supporting individuals. Anyway, that's just a bit of background about Inter Engineering and our mission and our vision for change. I'm really delighted to have a highly esteemed panel with us tonight, talking about the role that engineering has placed in the COVID-19 response. I'll get the panel to introduce themselves in a moment, but I'd like to just do some basic housekeeping in the first instance. So we are recording this session, so just to make you aware of that, with a view to us making it available afterwards. If you do have any questions for the panel, please put them in the Q&A at the bottom of your screens. I will be trying to multitask, keeping an eye on that, also fielding questions to the panel, but I really want a good discussion from tonight. So we're looking at doing 2 sessions. First session where we'll look at what the engineering response to COVID-19 has been, and then in the second session we'll look at more at the impact on equality in particular, and how we can still abide by the rules of inclusivity in times of rapid response when you might want to cut corners, but it's still important. So I'm going to hand over to our panel now to introduce themselves. Greg.
Hi, thanks, Mark. My name is Greg Turner-Smart. I'm a business improvement manager in civil aerospace operations at Rolls-Royce, based out of Derby. I'm actually in a bit of a transition period at the moment into a new role, which will be the inclusion and diversity lead for Rolls-Royce, and all being well, I'll start in that position next week. And on top of that, I also chair PRISM, which is the LGBT+ network in Rolls-Royce for the UK.
Hello, everyone. I'm Alex Smith, a Senior Programme Manager at the Royal Academy of Engineering. And prior to the pandemic, I was a policy advisor in the engineering policy team, where I spent my time understanding some of the engineering realities of complex problems and trying to explain them to policymakers, translating that solid engineering knowledge that our fellowship provides, and trying to make things more accessible. During COVID, I've had the joy of leading the Academy's Positive Response programme, so you'll hear more about that shortly.
Good evening, all. I'm Basit Abdul. I'm a healthcare scientist specialized in clinical engineering. I have two job roles at the moment, one at NHS England and Improvement, and the other one is at Barts Health. At NHS England, I'm a healthcare science fellow, where I help trusts, NHS trusts within London, Kent, Surrey and Sussex to grow healthcare science workforce, predominantly through apprenticeships. And my Barts NHS Trust job is more operational, where I help develop our clinical engineering workforce. I'm also on the NHS England Clinical Entrepreneur Program. My during COVID job is more on the response from the scientific directors team within NHS England, which I'll share in a minute during the discussion.
Lovely. Thank you, panel, for introducing yourselves. And as you can see, as you can hear there, we've got such a broad range of experience that you've each had individually in your day jobs that as of March, April, had to change completely or move to a completely different way of working from what you would have expected how the year was starting off. So we're just keen to explore that period of transition, I guess, and understand what it felt like personally moving into your new roles and what those new roles involved specifically with regard to engineering. So Alex, maybe if we could start with you, if you could talk us through what did you find yourself faced with back in March, April? How did it all start, this new role you took on at the Academy?
Thanks, Mark. So when the pandemic hit, my painful need to be useful and extreme nosiness meant I got myself immediately involved in some of the Academy's response activities. I typically lead our healthcare policy work and have a great network of sort of healthcare people across the fellowship and then also across the professional engineering institutions. So my involvement kind of spiraled from trying to be initially helpful into having the luxury, maybe luxury anyway, of being promoted to senior program manager for our wider pandemic response program. So I guess COVID has just like it has for all organizations, has really tested the Academy and made us try to work out what our role is in this kind of global emergency. Initially, we kind of refocused a significant portion of our resources in order to initially understand what engineering had to offer in the face of a crisis and to deliver advice to government. So we ended up setting up 4 strands of work across the whole Academy. The first of these was brokerage. So this strand was kind of set up to support our innovators and use our networks to make connections with the people who had great ideas that needed to get to maybe government or industry or funders. From this, we got to learn the breadth of what engineers could offer in a pandemic. And also, it's great to be on a panel with Basit, and we helped him identify over 1,000 engineers willing to volunteer for field hospitals. I'm sure he'll tell you more about that shortly. Then in our programs, we've been funding research, innovation, and collaboration for everything from software to help healthcare practitioners rebalance their caseloads to sort of cardboard coffins, the whole spectrum across the world. We've also been helping our African entrepreneurs to pivot their businesses or to produce PPE so that they can really manage that local need. Then communications obviously has been a key component of this to sort of ensure that the role of engineers is widely recognized. Our Innovation in a Crisis series, which maybe I'll touch on again later, has told some really empowering stories about people on the front line really collaborating to try to make a dent into the impact of COVID. And we also took a little moment to recognize all the engineers doing great things through our new Pandemic Services Award. So The final strand was around expert advice, and I guess this is where I've been losing some sleep. And we've completely changed how we operate, shifting to a much faster pace of providing rapid evidence reviews to ensure that that practical engineering advice was being considered alongside the typical go-to health and science experts. And when I say rapid, in some cases we had less than 24 hours to work out how ventilation should work in a Nightingale hospital and how it should be tested. And while I studied many years of mechanical engineering, I never really expected to have to use some of those fluid dynamics technical skills, which I'd long put in a box at the back of my memory. But then we did also get to do some slightly longer timescale things, understanding the implications of research and development, thinking about where engineering interventions could improve hospital environments and reduce the transmission there, and also in public transport, and then sort of trying to work out where the next supply chain challenges might be, and how we enable that critical flow of goods. Yeah, so I guess that's probably enough for me for now.
No small feat then. So you can see what such an integral part of the program and response for the United Kingdom that you played, the role that the Academy played. I remember receiving an email from the Institution of Chemical Engineers asking, you know, is this something you want to take part in, as an engineer registered with them? And so when I was invited, when we were discussing planning out this talk, and you recommended that we got in touch with Bassett to then to be in a moment now where the origination of that request to the engineering community, I'm really excited to unpick that a bit more and find out what that flow looked like, how engineers transitioned into the healthcare setting. So Bassett, maybe if we come to you next, can you just talk us through a bit more how you met Alex and what role engineers played in the response in the healthcare setting?
Yes, sure. One of the activities that I was involved from the scientific directors team within NHS England was to have the enough workforce. So workforce gap was identified very in the beginning, around mid-March time, and when the lockdown was initiated. We identified every hospital was increasing their ITU capacity, and also the addition of Nightingales clearly highlighted we need more and more workforce resources. So when I say the clinical engineering, so there are kind of two main parts. One is the engineering role to make sure medical devices are maintained, they are available, fit for purpose, and we were receiving thousands of new devices, make sure they have the right initial checks done before they reach to the ward. The other part, which is quite like linked with engineering, these are the people who are actually in ITU environment, but they make sure the devices are working. So they are kind of very much working near patient, providing the support, the technical support they provide. So we initially made a call to all the healthcare science community to volunteer for the services. So we recruited them and put them on a rapid training program. So that was another activity that I did, was to have the training program ready and upskill them ready to be available for Nightingale and other hospital. And I'm very glad we did in 5 days and delivered in 6 days. So 6 days delivery, we upskilled 60 healthcare scientists, but that was not enough. And we were clearly aware that although at that time the services were all other services were halted, as we know. So that's why these healthcare scientists were able to volunteer for the ITU or core COVID services. But sooner or later, they were going to go back for business as usual to provide their services. So that's why we reached out to this kind offer from Royal Academy of Engineering to reach out to broader engineering community for voluntary roles. And as Alex already mentioned, 1,000, it was amazing response received. 1,000 people, actually more than 1,000, registered within a week. I think it was initially, like first 2 weeks were literally the graph was increasing exponentially. So it was initially from London and then from the whole country. The idea was that we upskill them. So what we did, we created the training that was used for the healthcare scientists. The same or similar was used for other broader engineering community to again upskill them and use them for engineering services, not only at Nightingale but other hospitals in London. So my main focus was in London region, but same knowledge was then transferred to other regions of England.
That must have been such a very valuable repository of personnel. So how is it now we're in a second wave? How have those skills been retained? Have you retained a register to almost call upon should they be needed? What's been the ongoing engagement?
That's absolutely. And in fact, I had a meeting today afternoon, and we are working on, so for the second peak, we know those who volunteered, they were either furloughed or available at that time. So now we are reaching back to them. Initially, those who were trained. So there was a small proportion were out of this 1,000 plus who were given the training, and others were as a repository. So we are reaching out back to them to see who is now still available, so that we can, if we need the training, so we provide the training and have them available for the hospital. And also there are a lot of things to be checked to see they are deployed at the nearest location or their preferred location. So that is the activity, and also in terms of whether they are providing the service as totally volunteer or we need to recruit them as a bank staff within the NHS. So these bits are literally happening at the moment for the second wave.
There must be a lot of innovation learning there around a transfership program scheme en masse, essentially, taking skills from one bit of engineering and then putting them into another. I dare say some people may even permanently change careers potentially out of this.
That's true. We have examples where engineers, in fact, there are a few from the aviation industry, and as we know, some airlines initially furloughed and offered their engineers to NHS. So a few examples are literally from that engineering community that they have changed their careers and they are loving being a medical or clinical engineer now. So that's an amazing way of us being known now as a clinical engineer, and then appreciating by the remainder of the engineering community that this is something where we can make a direct impact on patient care without being a nurse or a doctor, which are, and of course they are the frontline heroes, but we are kind of unknown heroes at the back end, but having a better appreciation at all levels within the government, senior leadership, and even public. At least clinical engineers are now known by the fact that we maintain ventilators, because ventilator is something, a common phrase nowadays, and people are aware of it.
Absolutely, and that's a really nice point there, Bassett, for us to move across. And you mentioned, you were maintaining all this equipment, the engineers were maintaining this equipment, a library. In our briefing together, there was thousands and thousands of equipment pieces that had to be stored and indexed, known when to be retrieved, cleansed, replaced, maintained, etc. But the mobilization to get them to the point of you actually having the material, Greg, you played a part in your role involved just being redeployed 100% to the Ventilator Challenge UK. Can you just talk us through that and what that involved?
Yeah, of course. So it was a Sunday afternoon towards the end of March. I got a phone call from my line manager, And Rolls-Royce had been in conversation with the government and other parties around forming a consortium to deliver ventilators as part of the Ventilator Challenge UK. So obviously the call to arms came out. I was invited to join the core program team, and absolutely an opportunity not to be missed. Started work the next day, first thing, and from that point onwards, I was on the team for around about 5 months. And my actual role within the team, like many people in the team, it was quite varied, because there was an attitude of we just do what needs to be done. So there was no holding the baby, is the phrase we were using. You know, if you've got a task that's 80% done and you need to pass it on to somebody else because you've got other things to do, then you do it. So my role, you know, it could be anything from admin tasks. I was getting involved with finance, procurement, quality, some of the manufacturing issues and the quality concerns coming from there. Logistics. I was even a delivery driver at one point, delivering ventilators around. So it really was a case of all hands to the deck and doing absolutely anything that we could do to help.
And how did you, obviously it meant then a lot of parties coming together. So what Alex mentioned about supply chain partners and debottlenecking supply chains, etc. So how much did you leverage your existing supply chain? How much did you have to procure from new partners? What did that look like?
Yeah, so we received the bill of materials for the Smiths Parapack ventilator, which is the one that we were tasked with sourcing. To give you an idea of the scale of things, the bill of materials has around about 300 unique entries on there, so 300 different parts that needed to be sourced. And the initial aim was to produce 8,000 ventilators. So when we do all the maths on how many parts we need, we're looking for 3.4 million parts to be procured from scratch and delivered in just a matter of weeks. So a huge ask. We did set up multiple commodity groups within Rolls-Royce. So each of those had a program manager who was leading a team looking at certain sections from that bill of materials. So each group had a list of parts that they needed to source. And obviously they all had their own approaches, but the first point would have been our existing supply chain. We do have a very large supply chain within Rolls-Royce, and where we could use existing supplies, and absolutely we did. Wasn't that straightforward. So many of the parts in the ventilator are actually made from plastic. So producing jet engines, because you can imagine plastic parts don't tend to work very well in the jet engine. So many of our suppliers had little experience of working with plastic and simply couldn't do it. The additional challenge to throw into that was that we weren't allowed to touch the incumbent supply chain that Smiths were already using for their product. So that supply chain was still in action and still manufacturing and producing for them. So one of our sort of criteria or limitations was we weren't to go near that incumbent supply chain because we didn't want to disrupt the existing flow of ventilators coming through there. So yeah, it was creating that network, a real positive response from manufacturers right across the UK. Everybody wanted to be involved. Everybody wanted to help however they could. And even if that was the message of, we can't do this, but we know somebody who can. So it was brilliant to see that collaboration between the suppliers in the supply chain and using those contacts and those networks to pull those people together.
Fantastic. Thank you for that. So, I mean, you've all had to really repurpose, reshape, pivot, all the other words that we use to describe moving to a new norm. Before we move on to the next section, just maybe what are some of your key lessons that you've learned then in having to deal with a pandemic in a time of transition? Like what are some of is there anything you can share from it can be a personal perspective or from a professional perspective? Like how if we're ever in this situation again, you know, how confident are you that we can address the new challenges or the challenges that we know of that we face in the future as an engineering community?
Who you want to go first?
I'll jump in. Yeah, so it's been really interesting to hear Greg talking, and we've been running a bit of a event series called Innovation in a Crisis, having chats with those inspirational engineers on the front line, those that have been building Nightingale hospitals or producing PPE and ventilators and designing new technologies to make workplaces more COVID secure. And across these, we've started to like pull out some key common trends, the sort of power of the clear, compelling goal that everyone can rally around and be inspired by. And then that role of people and their individual skills, but then also their relationships with others and their ability to collaborate are like so valuable and completely at the center of both Greg, Bassett, and my stories. Then also what's quite interesting is the forced disruption that has been caused by something that makes people work remotely, or just completely different ways of working, to make us all a bit more cross-sectoral, a bit more digital, and that's like added an additional flexibility and hopefully like a capability that is agile and we will keep. And then the final one is kind of the role of organizations such as regulators and standards, and them also being agile and sort of responding with the needs of the engineering community and the needs of, I guess, hospitals as well, and trying to navigate the way through these kind of complex structures whilst also ensuring that all products meet necessary safety standards and no one's lives are compromised by sort of cutting corners or that kind of thing. So I just wanted to share those kind of high level common themes, which I think will run through quite a lot of the rest of our conversation.
Absolutely, and I hope that we, a lot of what you just listed there, we retain, we keep. We might go a little bit back to what it was like before in terms of our work-life balance or how we work, but I certainly hope the shift to what you've described is something we it's indelibly changed the way we work, I feel, in some respect. And then hopefully that helps attract new people to the profession because of the skills gap that we have. Bassett, what are some of your lessons that you've learned that you'd like to share?
I think Alex has very nicely comprehend the whole learning package. Just one, I think it will be a repetition as well. If I pick only one lesson, I think it is about networking. We need to talk about network and communicate better. One of the major tasks within the team I supported was creation of the London Clinical Engineering Network. As we know, London was the first peak, and we were kind of quite ahead of things. So, and that London Clinical Engineering Network was then replicated with the rest of the country, and then so this London Clinical Engineering Network means that we started having weekly calls. It was like Wednesday 8 a.m. call chaired by Ruth Thompson, and all around 33 trusts within London, their heads of clinical engineering, they were sharing their issues, sharing intelligence, sharing inventory, and solving problems. And that kept for a very long time. And now we are moved to every other week. So this networking, I think, or communication is the key, because this saves you reinventing the wheel. Sometimes the solution is just literally a call or an email away, and it saves tons of time. And especially during pandemic, time is the key. So if we have a network established or well established, then they can be of real use to solve the problems at a pace. So yeah, that's from my side.
Love it. That's a very, very good piece there. Greg.
Yeah, I think that's a really good point that Bassett's just made. Actually, if we were to have to do this whole ventilator challenge again, we're in a much stronger position now because of that network that's already been established. So that's half the job done in many respects. In terms of what we've learned, I think a different maybe spin to what the others have said. For us, a lot of our lessons learned have been around the need to operate and work at pace. So urgency was absolutely critical for us. And in the world of jet engines and what we normally do, things moved at a much slower pace. So we don't normally have projects with timescales and deadlines quite like this. The way we set it up, as I mentioned before, with these different commodity groups, everybody that was brought onto the team was 100% focused on ventilators. It was absolutely made clear to everyone, We don't deal with emails on the day job stuff. We don't take phone calls. We are focused 100% on this. So to have those teams created within the group, everybody focused on one thing, and then those teams were set up with the relevant resource that was necessary to deliver. So each team had a PM leading it, a quality engineer, a manufacturing engineer, somebody from purchasing, so that they had all the resource they needed around them, dedicated to that work 100%. And that helped to really deliver things much more quickly than if people were trying to juggle 3 or 4 projects at once. And there's a whole debate we've had ourselves around which is the best approach to take. But certainly in this circumstance, it was absolutely the right thing to do, 100% focus with all the resource at hand. And that helped us to really get through there much more quickly than we perhaps otherwise would have done. Operating at that kind of pace, though, it's going to lead to mistakes, it's going to lead to errors. And very quickly, we had to get into the mindset of we will make mistakes. We recognize them, we acknowledge them, we correct them, and we move on. So we don't linger over the mistakes that we've made. We don't worry about it. If we've made some kind of an error, we'll fix it. We'll get the help we needed. We'll move on. And everybody was doing that. And that's a consequence of working at that kind of pace. And as I said earlier on, there's no holding the baby. So we didn't want individuals to be bottlenecks. If you're getting too much on your plate and you can't manage everything you've got, let us know. If we need to bring more people in, we'll bring more people in. If somebody's got a spare half an hour until they've got a phone call, they'll go around the office and say, what can I do to help? So real good team ethic and work ethic to help everybody else out so that we can just continue to work at that pace that we needed.
So really what we're also doing there is challenging the stereotypical way in which engineers like working, lone working, sort of very involved in the mind, analytical, to not even being able to check your emails or pick up the phone. That is pure focus. You can't I can't imagine doing that, being 100% focused on
and for me personally, it was quite refreshing. So instead of jumping between different jobs and different conversations, you just have that pure focus on one task, and that's the task at hand. You know what your number one priority is, you know what you need to do, and it is a different mindset for a lot of engineers being told, actually, you need to pass that on now, even though it's only 80% done.
Yeah.
But it really was quite a refreshing way to work in a perhaps perverse kind of way.
And I guess this actually moves nicely on into our second part of our topic around looking at equality in the time of turbulence, transition, and uncertainty. So Greg, you mentioned in your intro that you are chair of the LGBT network at Prism. So what, being part of a network within the business of an employee resource group and leading it as well, what benefit did that bring in the response within Rolls-Royce to the call to arms, essentially?
Yeah, I think for me personally, the benefit was I'm quite well known around Rolls-Royce as chair of Prism. We're quite a visible network and quite well known within the company. But I don't want to be known as just the guy who leads the LGBT network. Actually, there's more to me. I've got a whole career and I've got my qualifications and 20 years of experience behind me. So I'm not just, the gay guy who leads the network. So for a personal benefit was actually to be involved in quite a high profile piece of work, but then people to realize actually there's more to me than just the LGBT stuff that I'm involved in. That in turn, I think, can lead to a benefit for others to see an LGBT plus person as a role model involved in a high profile project and doing a pretty decent job of it. And what I hope that work has done for others in the company has made them realize that you don't need to hide in the shadows, that you can be yourself and still have these fantastic opportunities to really make a difference. And sadly, we do still hear from people in Rolls-Royce who are worried about coming out at work and the impact it might have on their career. And people do tell me they'd rather stay in the shadows almost, keep quiet, not be themselves. But I hope what this might teach them is that actually, if you stay in the shadows, you're not going to get the opportunities that you deserve, and you're not going to get that exposure by hiding away. So sometimes you have to step up, you have to have a bit of courage. But if you come out and be yourself at work, then you're going to have a much bigger opportunity to flourish and then get involved in these kind of projects.
Yeah, and I think a lot of people still question that from the misunderstanding around sexual orientation and sexuality, and they don't see the link between being your true authentic self at work or the talking about the gender of your partner, etc. You know, that does play a toll on hiding or masking when that translates through to product. I remember reading a statistic somewhere, I think it was in Lord Brown's book, actually, The Glass Closet, who we did an event with last year for LGBT STEM Day. And it was like, people can sense if you're in the closet, and there's that sense of mistrust that gets formed. They'd actually rather that you were out, and then people would know who you are, because it builds better trusting relationships. All that time hiding who you are. And certainly in inter-engineering, we still get you know, emails that come to us from engineers that are in that predicament. And so I hope that by doing events like this, showcasing the talent, you know, the leadership role that you're ascending to, Greg, within Rolls-Royce, that it does encourage anyone who may be in that mindset to you know that it's okay. And so I guess when you're in a time of turbulence and when you're having to move quickly and move at pace, there's a lot of checks and measures that we have in place, particularly from the Cabinet Office when it comes to public procurement, public spending, public sector equality duties, equalities impacts assessments that are usually done as part of the tendering process. Does all that just go out the window when you're responding to a pandemic? How do you ensure equality is within what you're doing? Alex, how do we in the future then, from what lessons have been learned throughout the pandemic response, and how do we build back better, as is getting used now as a term, in future responses to make sure we are being equal for everyone?
Yeah, I think it's definitely a challenge, and I guess I'm not going to comment on the procurement question specifically, as it's not something I have experience of, but I think we've seen how COVID has transformed our lives this year, really has just exacerbated so many existing inequalities, whether that's due to gender, race, sexuality, class, or age. And one thing that I've personally learned, especially in my role trying to collate evidence, is in normal times we'd spend a long time mapping out the stakeholders, understanding different characteristics, different needs. But when you're responding at pace, unfortunately, a lot of that you just don't have time to do it. And especially when you're drawing on partners such as colleagues in the National Engineering Policy Centre, you're kind of outsourcing that answer, and you're not quite sure or you don't have time to sort of ask who they're asking. And when it's a network of engineers, we obviously have the baseline problem of the lack of diversity, which just amplifies the challenge that we have further. But I guess, like, as we move into more proactive work, just to comment a little bit on the reactive stuff, I guess I took a bit of that burden on myself, and in collating the responses, trying to look for the points where we could potentially flag co-benefits of sort of lower no-touch technologies in office spaces. Would that also be beneficial to disabled colleagues? Or also trying to avoid additional adverse consequences, depending on sort of what interventions you chose on public transport, or sort of thinking about how hospitals were brought together. It was very much about bringing all those different stakeholders together and making sure those views weren't excluded. So while it was very difficult to collect the usual diversity of views, we tried to cover that in what we were putting together. And I guess the Academy is a strong champion of thinking like that, and that helps. But then as we move to the more proactive work, we've been able to actually think about diversity and inclusion. And I guess as we think about building back better, as you've said, the importance of diversity and inclusion needs to be at the forefront of that narrative. We've recently published a paper asking government to use this opportunity to prioritize diversity and inclusion for jobs and skills to reverse those COVID impacts, and then also just to help us progress towards net zero and the net zero target and building that additional capacity. And we should never forget the co-benefits of diversity, improving innovation, and really ending up with a better product, a better society, a better policy, whatever that may be.
Definitely.
Just to add as well, I think it's great to see SAGE, the Science Advice for Emergencies group, taking this challenge seriously and sort of setting up an ethnicity subgroup to try to disentangle some of those particular challenges around that one dimension of diversity. But yeah, it's a small step.
And it's an important step that at least is being taken. And your point is very valid there around if we inherently have more diversity within engineering, visibly and hidden, if we change the composition of who our engineers are within the United Kingdom, when we have to hive our response to any of these predicaments that we face, either at pace or over a longer time scale, we'll inherently have more diversity of thought, experiences, frames of reference contributing to the solutions that we're coming out with. Bassett, how did you find, what did you and the team do to maintain a sense of self and normalcy, I guess, in your response? How did you manage that? You're on mute. You're about to start.
In my case, it was I was, because of having two jobs. One within the NHS England, because we were a group of 5 healthcare science fellows reporting to the scientific director, and from day one we were told to work from home. As still NHSE is, we are working from home. So it was challenging on various levels. Some people found it very productive, useful to be working from home, at least in the early days. But however, the others have a variety of reasons finding working from home a bit or sometimes quite challenging. And on top of that, we were literally kind of working for 12 hours or more, from morning to evening in front of the big computer screens and working. And that had we started to feel the toll mentally and physically, and in response to that, there were a lot of resources, honestly, from NHS England and the relevant bodies, and as well as the commercial sector. So we were shared with, as we know, NHS workers were given free meals, free cycle rides, all this known stuff, but also mobile phone based like apps for mental health, for some mindfulness, sleeping. These kind of various supports were available, and each team leader, they were also given training to have debrief meetings. So we were having on daily basis debrief meeting, and the idea was not to talk about work, but also at a personal level, that how we are dealing on a particular day. That was extremely helpful. On the other hand, from the engineering side, where all of my colleagues, they were working on workshops on day to day, they were having their own challenges. At one point, some of the hospital engineering workshops were depleted to even half or more because of people isolating themselves, some COVID sick, and so on. And in clinical engineering community, and luckily, at least in more in London region, the population is quite diverse. You can see a lot of BME population, and we know on BME population, we were already on a moderate risk. So there were pros and cons, of course. And those challenges, because again, clinical engineering workshops are often found in the basement or somewhere in the hospital, not enough even windows to the workshop. And it is quite challenging and because of listening all the time about the COVID and whether we use mask, whether we don't use mask, what is the government guideline at the moment, where we stand at the moment. So things, as we know, throughout these last 8-9 months, regulations and guidelines were changing on daily basis. And working in close proximity in an engineering workshop was bringing its own mental toll. So challenges were on various levels at diverse. They were very diverse. But I think in overall we managed well. The support given to us was very good, and they were at various levels. NHS were doing their job. Health Education England, they were providing all the time various guidelines. The Chief Scientific Officer's team, they were also providing support and guidelines and resources. Even hospital library services, they started to create calm zones, people to just go there and just relax for at least some time. And for engineering community, there was another change. Generally, we are 9 to 5 working people, but at Nightingale, our shifts were 12-hour shift, just like any other staff member. So that was another change. And because of having perhaps older people or shielded people at home, engineers and other our colleagues, they were living at hotels, of course, which were provided to us, which is great support, but it had its own challenges with it. So there's a long list, of course, when we can talk for ages, but on the same side, I think, and me as a part of International Federation for Medical and Biological Engineering, IFMBE's CED, which is Clinical Engineering Division, I was having another side of the rest of the world from the engineering community, and we had a WhatsApp group where we were receiving information and learning from all over. And very often, or there was a time I was feeling and I was sharing with my colleagues how grateful we are, because the number of, if we just talk about ventilator and ignore all other medical devices related to that, there are countries where even the total number of their ventilators available in the whole country were less than available in London only. So we were in a many ways grateful situation, and I think that sharing of knowledge was helpful at some point.
And I guess there's something there at Bassett around how, as a nation, as a developed nation, we sort of help other economies, other emerging markets ensure their preparedness in the future is better. They've got the ratios there, sharing lessons, and your WhatsApp group point there echoes back to your point at the beginning around connectedness and networking and connection, and to have that viewpoint on the international scene must have been very insightful and informed. It must have been quite a challenging environment, Greg, at Rolls-Royce. What were some of the personal challenges, or what were some of the biggest technical challenges that you faced, and how did you overcome them?
I think in terms of personal challenges, it was the intensity of the hours we were working. So those first 3 weeks especially, we were looking at 14-hour days, 7 days a week. So we had to be really, really mindful, again, as Bassett said, around mental health, keeping an eye on everybody, make sure that we're all in good working order ourselves. One of the things we did there, it was about 3 weeks into the challenge, was Easter Sunday, and the whole consortium put a rule in place saying that nobody was to do any work on Easter Sunday. We needed a day off and we needed a break. And that was really well respected across the consortium in terms of not a single person did anything. So all we needed was one person to send an email, and then suddenly the recipient feels obliged to respond, and then the benefit has gone. So it was fantastic to see everybody observe that really simple rule. And actually we came back not just refreshed, but much more productive by having had that that day of. And the other thing we did as well to make sure we helped people was to try where we could to get people's families involved. So there's a couple of examples within the teams where some of our engineers who had young children, they were getting their children to help them out on some of the work. So it would just be something like double checking a report or reviewing some numbers for them. But it was just a way to actually have that interaction with their family, which obviously was a big morale boost. But then the knock-on benefit of trying to get their children interested in what the parent does for a living, get them involved in STEM types of subjects, and make them interested in engineering as a career. So that was a really good way to try and overcome that intensity at the start that we were facing. In terms of the technical challenges, I think it's really, really difficult when you're working on somebody else's product, because all of that tacit knowledge is with the owner of the product. So we had a really good relationship with Smiths. We were getting a lot of their expertise out of them to help when it came to some of the technical issues. But of course, there's always things hidden away in somebody's head that isn't in the documentation. So another really good lesson learned: keep your documentation up to date, because it's so important. And when we look at some of the technical drawings, some of those were decades old and out of date, no longer applying to the correct standards. So that raised a lot of questions, and it was actually a good exercise to go around and understand what these drawings were actually telling us, because it didn't necessarily line up with what we expected to see. So having those conversations with Smiths, looking at those drawings, understanding the technical aspects, we were fortunate. We've got a wealth of manufacturing and materials expertise within the company. So we brought a lot of people in from those areas to help us with that and to understand what we needed to do to make this work. And we touched upon materials earlier on as well. That links to medical standards. So obviously we're used to dealing with aero standards. Both are very, very strict, safety critical. So that's an advantage, but also completely different. And one of the things we learned about, which we hadn't really thought, I don't think, up front, was around some of the plastic materials. And if any plastic material, if we couldn't source the actual material, we were looking at alternatives. But what we learned was that if those plastic parts fall in the gas path, in other words, if it comes into contact with oxygen, which is going to go to the patient, it must be the material that is specified in that document. So the danger was there's going to be some kind of reaction, and instead of putting oxygen into the patient, we're putting toxic gas into them, and obviously having the opposite effect of what we're trying to achieve. So lots of lessons being learned, lots of challenges, all very, very new compared to what we were used to.
Wow. I've been writing down lots of like little notes here, because you've all alluded to something that really we should be capturing for the entire industry, as lessons learned on any sort of project. Keeping your documentation in check, that good old printing it off and having it in a folder on the corner rather than it getting lost in a file architecture, and that cross familiarity the engineers have with standards and high safety requirements can still bring a false sense of security potentially when you're moving to another bit of the industry. So I'd just like to take the opportunity to say thank you to Greg, Alex, to Bassett, all for giving up your time to talk this evening. Thank you to the Academy, the Royal Academy of Engineering, for hosting us, for being a brilliant partner to work with, on these events that we run, that hopefully can help share knowledge across the people who are here listening in and beyond. And thank you to the team at Inter Engineering as well, for all the work that you do in the background, running our events, maintaining our website, communicating with our members, facilitating events like this. It wouldn't happen without the strong volunteer base that we have. So with that, I'll bring the session to a close and hope to wish you all a good evening, and enjoy the rest of your week. Thanks, everyone.